Alright, so the last video in this first chapter is going to be when we look at rationalizing the denominator. So we looked at surds in the previous video, but when we have a fraction where there's a surd on the bottom, it's very hard to manipulate or to use. So what we would like to do is make the denominator a rational number, i.e. having those surds. So there's three different forms or ways of doing it, depending upon the form of the fraction. So first things, if I have like the surd on its own on the denominator, what I have to do is just multiply this by the root of the surds top and bottom. So root x over root x. If I have in this form where it's x plus root y, then it multiplies top and bottom by x minus root y and x minus root y. If I have in this form, if it's 1 over x minus root y, then I multiply top and bottom by x plus root y and x plus root y, like this. So depending upon the form of the rational or the irrational number, then the way we rationalize the denominator is using these different techniques. So let's look at some examples. So let's say I have 1 over root 2. Okay, so as you can see from the first one, I multiply top and bottom by root 2 and root 2, leaving me with root 2 on the top, and then root 2 times root 2 is root 4, square root 4 is just 2, like this. Now the denominator is a rational number, there's no surds there. Let's try a value where we have maybe 2 over 4 minus root 5. As you can see, we want to multiply this by, this is a negative value here, just think of it as the opposite sign. So it's going to be 4 plus root 5 and 4 plus root 5. And now it's just a matter of multiplying each one separately. So on the top, we have 8 plus 2 root 5. On the bottom, we have 4 times 4 is 16. 4 times root 5 is plus 4 root 5. 4 times minus root 5 is minus 4 root 5. And then minus root 5 times root 5 is minus 5, like this. And as you can see, these two cancel out. So you're left with 8 plus 2 root 5 over 16 minus 5, which is 8 plus 2 root 5 over 11. Okay. A quick hint or a quick way of doing this is, right, we don't have to actually write out this bottom part here. What you can just simply write is, well, the denominator is just going to be the first number squared, so 4 squared, minus the second number squared, so 5. That's what we get, 16 minus 5. So that's a quick way of writing it out. Let's do another example. So let's say we have the square root of 3 minus the square root of 7 over, let's say, square root of 3 plus the square root of 7. So once again, we multiply top and bottom by the opposite sign. So it's going to square root of 3 minus root 7 in this case, and square root of 3 minus root 7 in this case as well. Right, as I said, the denominator, just imagine just squaring each number and then doing minus in the middle. Okay, so root 3 squared is 3, root 7 squared is 7, so it's 3 minus 7 on the denominator. The numerator you have to multiply out individually. So root 3 times root 3 is 3. This times this is minus root 21. Here we get minus root 21 as well, and these two multiplied together we get plus 7, like this. So we're gonna have 10 minus 2 root 21 over negative 4, like so. And we can simplify it even further by dividing by 2, so I can get 5 minus root 21 over negative 2, like this. Maybe let's try one last one. So let's say we have 4 over 3 minus root 2 squared. So as you can see, we have the squared on the denominator now, right? But we need to expand that first before rationalizing it. So it's 3 minus root 2 multiplied by 3 minus root 2 and 4 over that. So we're going to have 9 minus 3 root 2, 6 root 2 plus 2, 4 over that. So we're going to have 11 minus 6 root 2 and 4 over that as well. Now we got in this form, now we can rationalize it. So we multiply top and bottom by 11 plus 6 root 2, 11 plus 6 root 2, like this. Remember, the denominator is always just this squared minus this squared here, right? So it's 11 squared is 121 minus 6 root 2 squared is 672, like so. And then it's just a matter of multiplying the numerator. 4 times 11 is 44, plus 4 times 6 root 2 is 24 root 2, like this. And then it's just simplifying it and finding the final answer. So that's the way we rationalize a denominator, because we don't want to insert form, because it's a bit more difficult to manipulate fractions if we have a surd on the denominator.